Today we are going to talk about vectors. Now, what is a vector? If I ask you, what is the speed of wind? Is it enough to say that wind is blowing at 5 kilometers per hour? Okay, that is one part. But what about direction? Oh yes, it has got direction as well. So, we are talking about quantity of a vector quantity A vector has two components to it. One component will be its magnitude and another is direction. When we say wind velocity is 5 kilometers per hour, this part is the magnitude of it. And we have to give the direction as well. We may say it is blowing in northerly direction. Okay. So a vector has two components to it. One is called the magnitude and another is called the direction. Now, how is it different from non-vector quantity? Okay. Let's talk about a scalar quantity. A scalar quantity has only magnitude and no direction. Okay. When we say what is your weight, you may say my weight is 50 kg. Do we say what direction? No, because weight does not have a direction. So you see the difference? A weight parameter and a wind velocity parameter. Wind velocity will have direction as well as magnitude, but a scalar quantity will have only magnitude. Magnitude and no direction. Okay. So this is the basic difference between a vector quantity and a scalar quantity. Okay. Now, if we say today the wind is blowing at 3 times, it was blowing on Monday. So we say today's wind speed is 3 times it was on Monday. And on Monday, it was, let us say, 5 kilometers per hour in northerly direction. So we can easily say that today the wind direction is 15 kilometers per hour in northerly direction. Okay. So what it means is when we multiply a vector quantity by a simple number, the number gets multiplied, the magnitude gets multiplied by that number, but the direction does not change. Direction remains the same. Okay. Now let's talk about vector additions. Can vectors be added? Yes, vectors can be added. For example, there's a river which is flowing in this direction, and there's a swimmer which is trying to go in this direction. Will he go to the other side of the river like this? No. Why? Because there are two vectors working on him. One is the direction of flow of water in the river, and another is his effort to swim. So he will reach somewhere where you have the resultant of these two vectors. Okay. That means the two vectors are getting added to give you a resultant. So formally what we say, today we will seek addition of two vectors, how two vectors are added to each other. Okay. The two vectors can be added component wise. The best thing is that we break each vector into its subsequent components, which is in x in I direction plus ay in j direction plus a in k direction. Now ax is the component of a in x direction. When we write I means this is unit vector I. Unit vector I is representing x direction. Similarly, unit vector j is representing y direction and k is representing z direction. Okay. And when we add, similarly, the components of b, bxi plus byj plus bzk, the addition will be done component wise, so it will be ax plus bx in I direction plus ay plus by in j direction plus az plus bz in k direction. So this is the simplest way of adding two vectors component wise algebraically. We can also see how two vectors are added geometrically. Okay. Let's see, we have a component A here. Then we have a component B in this direction. How can we add them geometrically? Okay. What we do is we take component A whose magnitude is proportional to A. All right. Now this vector is represented like an arrow. This is called the foot of the arrow and this is called the head. This area is called the head. Now to add another vector, what we do is we go to the head of the first vector, align the tail of the second vector and draw a parallel line with the magnitude same as this magnitude, or length should be same as this length. When we have added these two, the resultant will be shown by vector going from the foot of the first vector and the head of the second vector. This will be called A plus B. Okay. Geometrically, also we can do, what we do is we draw vector A parallel . This is A. This is B. And the resultant is, as you can see from the diagram, the resultant is given by the diagonal of the parallelogram. Okay. Now, if we have two vectors A and B who are separated with an angle theta, can we predict what is going to be the resultant A plus B, this alpha? Suppose the resultant A plus B makes alpha with vector A. Can we calculate alpha? Yes, we can. Tangent of this alpha is given by B sin theta divided by A plus B cos theta. You know the magnitude of each vectors. You know theta, and this will give you cos of tan of alpha. Okay. So this was about addition of two vectors. Now we talk about dot product. Dot product is also called as, dot product is called scalar product. By the word scalar, you know that a quantity which has only magnitude and no direction. Okay. Now, how is it represented? It is represented like this: A dot B, and is also equal to A times B cos theta, where theta is the angle between vector A and B. Okay, so there is no direction. That's all to it. We have quantity A, magnitude A, magnitude B, multiply by the cos of angle between them. That's about it. There's another way of calculating dot product, and which is by taking its components. So component of A in x direction is component of y, A in y direction, component of A in z direction is this, dot bx I, component of B in y direction, component of B in z direction. Now the dot product will be all individual terms have to be multiplied by each individual term of this one, which means we have to take dot products of this with this plus dot product of this plus this plus dot product of this plus this, then dot product of this with this plus this plus this plus this into this plus this into this plus this into this plus this into this. Now what you see it here that when we multiply component with I direction to I direction, the angle between two I directions are 0. So cos 0 is 1. This is the only component that will be effective. If we multiply I with j, the angle between them is 90 degrees. So the product will be 0. Again, if we take I component and if I take I component and multiply by k component, since angle between I and k are perpendicular to each other, cos will be 0. So the effective product will be multiplication between same vectors, which is Ax gets multiplied by Bx plus, that's the only one, because Ax product with other components in j direction or k direction will be 0. Similarly, Ay will give effective components with by plus z component of a multiplied by b component of z. This will be our effective a dot b. Okay. Now we come to second type of multiplication, which is called cross product. It is also called vector product. Now, as the name vector suggests, you must be immediately saying, yes, it is a vector. So it will have two components, right? And this will have magnitude. Second will be its direction. Okay. How do we do it? All right. Cross product is written like this: A cross B, which is equal to A times B times sine theta. Theta is the angle between vector A and vector B. Is that all? What else? What about direction? Oh, yes. We have to have direction also. Now, what is the direction of A cross B? The direction of A cross B is perpendicular to A as well as B. If I show you, it will be something like this. If we have A here, if we have B here, the direction of A cross B is perpendicular, right? This is making angle 90 and this also is making angle 90. All right. But is this to go upwards or downwards? Yes. How do we find out? Simple. What you do, this is resolved by right hand rule. What does this rule say? This rule says, put your hand at the junction, then curl your fingers in the direction you have written this. A to B, A cross B. A cross B, by the way, this is not same as B cross A. We'll see this why it is not so. So when we say A cross B, curl your fingers in direction so that your fingers go from A to B like this. And your thumb will be giving the direction, whether it is upwards or downward. Okay. The right hand rule says, curl your fingers in the direction of cross product. Then the thumb will give the direction. Okay. If it were B cross A, you know, your fingers should be crossing this way, and your thumb will go downwards. That is why A cross B is not same as B cross A. In fact, A cross B, if you want to reverse the direction, is negative of B cross A. As we saw it here, that when we change the direction, our thumb direction became negative, like this. Okay. Let's talk about few entities. We have already seen one entity, which is this. Another is, if we multiply A cross B plus C, this is same as A cross B plus A cross C. Okay. Is it correct? One will say, what's wrong with it? It's simple. Opening the brackets. No, it is wrong. Cross product of A with sum of two vectors doesn't open up like this. Now, if we want to compute A cross B, it is best to do component wise, which was like what we did earlier, the scalar product, xi, A, yj plus A, zk cross, this is our A resolved into components in each direction, then B xi plus byj plus bzk. This is whole of B. Now when we do a cross product, what we have to do is we have to do this cross this plus 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 this cross this. Okay. So each component will have to be done a cross product with each of the component of the second vector. Now when we evaluate everything, this boils down to, this is equal to ax bx plus no, sorry. This will be ay bz minus az by. This is the I component. Similarly, az bx minus ax bz, this will be in the j direction, and ax by minus ay bx in the k direction. This is all plus plus. This is A cross B. This is A cross B. Okay. Let's take a small example to find angle between two vectors. Let us say we have a vector A which is equal to 3i plus 4j minus 5k, another vector B which is equal to 5i 4j plus 3k. When you write a vector like this means vector A has 3 units in I direction, which is X direction, 4 units in J direction, which is Y direction, and 5 units in negative K direction, which is Z direction, minus 5 units in Z direction. Okay. Now, when we do A dot B, what we will get? We have seen the formula earlier. We will get 15 plus 16 minus 15, which is equal to 16. And what will be A, B cos theta? Because A dot B is AB cos theta, which is 16. And what is A? A we can evaluate. Square of each terms added and taken the under root, which is 9 plus 16 plus 25 is equal to 50 root. This is A. Similarly, B is equal to 25 plus 16 plus 9 under root, which is again 50. So we know A. We know A. A was square root of 50. B is here. B is again square root of 50 into cos theta is equal to 60. So this is 50 cos theta is equal to 16, or cos theta is equal to 60 by 50. So this way we can find out the angle, cos of angle, and hence the angle between the two components, the resultant between the two. Theta here is, as we have seen it here, AB cos theta. When we say A dot B, it is AB cos theta. Theta is the angle between vector A and B. Okay, let's say if it was A, this B, then this is theta. Right. Now, what we have seen here is how to add vectors, how to multiply vectors. But can we split vectors? Yes, why not? We can split vectors also. Let us say I have a vector A and I want to split it in a direction which is theta from here, and another component which is perpendicular to this. Okay. So component of A in this direction will be A cos theta, where theta is the angle between vector A and one of the direction in which you want to resolve it, which is making angle theta. If it is making angle theta with it, component of A in direction perpendicular to it will be A sin theta. Okay. Now, if you don't want to take this theta, you want to take take angle from here. All right, no problems. If this is the angle alpha, then this component will be a cos alpha, and this component will become a sin alpha. All right. So this is pretty much all what we have to talk about vectors. Thank you.